Okay, so in this video, we're going to talk about the nature of quadratic roots. Again, the maths here is going to be very straightforward. It's just the theory. There's a bit of learning work to this. Before we delve too deeply into the theory, let's just do one example where we find the discriminant of a quadratic. Imagine I gave you the quadratic equation x squared minus 4x minus 9 equals 0, and I asked you to find the discriminant of the quadratic equation. You've found the discriminant of quadratic equations. You've been finding it since third year. It's part of the minus b formula. At junior cert level, when you have a quadratic equation that you can't factorize in your head, you use the minus b formula. And think of the bit that's under the square root on the top of the fraction. Under the square root on the top of the fraction of the minus b formula is b squared minus 4ac. b squared minus 4ac is referred to as the discriminant of a quadratic equation. And if you can work out what the discriminant is, you can tell whether a quadratic equation has two real roots or two equal roots or no real roots. Basically, the discriminant tells you the nature of the quadratic roots, or the nature of the roots of a quadratic equation. It's incredibly easy to get the discriminant. Just think back to what you did at junior cert using the minus b formula. A is the coefficient of x squared, in this case 1. B is the coefficient of x, in this case minus 4. And c is the constant at the end, in this case minus 9. So if I asked you to get the discriminant of this quadratic, you'd simply write out b squared minus 4ac and then sub in. In this case, b squared would be minus 4 to be squared, and I'd get minus 4 times 1 times minus 9. Now minus 4 times minus 4 is 16. Minus 4 times 1 times minus 9 is plus 36. So if I add 16 and 36, I get 52. So the discriminant of this quadratic equation is 52. Now that we know how to get the discriminant, let's have a look at what that tells us about the nature of the quadratic roots. Okay, the first scenario is where you have a quadratic equation that has two distinct real roots. What that means is two distinct just means different, two different real roots. The vast majority of quadratics that you've come across have been quadratics that have two distinct real roots. I've just drawn a rough sketch of what it looks like. Basically, it's just a quadratic curve that crosses the x-axis in two different places. In order to prove that a quadratic has two distinct real roots, then you need to prove that b squared minus 4ac is greater than 0. So for example, the one that I just did in the previous one, b squared minus 4ac was 52, which is clearly greater than 0. So that was an example of a quadratic that has two distinct real roots. But that's only the first scenario, and there are three other scenarios that we need to deal with in terms of the discriminant. The second scenario is a quadratic that has two equal real roots. Two equal real roots. You would have come across this a few times at junior cert level. It's a quadratic equation that turns on the x-axis. Like for example, imagine I drew a quadratic that turns, it has a turning point at the point 3, 0. It still has two roots, it's just that both of the roots are the same. If this was a quadratic that crosses at x equals 3, or in other words that turns at x equals 3, both of the roots are x equals 3, so I'd have to write it as x equals 3 and x equals 3. If you take a quadratic equation that turns on the x-axis, or in other words that has two equal real roots, then the discriminant will be equal to 0. b squared minus 4ac will be equal to 0. So that's scenario number 2. The third scenario is where a question simply says, prove this quadratic has two real roots. Essentially, it means that it's either scenario number 1 or scenario number 2. If an exam question says, prove the quadratic has two real roots, that means that either you're dealing with two distinct real roots or two equal real roots. It's open-ended. They're not specifying which is the case. Which means you need to prove that b squared minus 4ac is greater than or equal to 0. So that's the third possibility. If an exam question says prove a quadratic has two real roots, this is your instinct. Either b squared minus 4ac is equal to 0 or it's a positive number. Okay, the fourth scenario here it's important in algebra, but you'll understand it a lot more when you've studied complex numbers. Every quadratic equation has two roots, and there are no exceptions to that. However, you could have a quadratic equation like this. The quadratic equation I've sketched here doesn't cross the x-axis, which means it has no real roots. It still has two roots, and we refer to those as two complex roots or two imaginary roots. There's an entire section in maths dedicated to complex numbers, and when we deal with that, we're going to be dealing with quadratics that have no real roots. All that really comes up in algebra is you need to be able to prove that a quadratic has no real roots or complex roots or imaginary roots. To prove that, the discriminant must be negative, or b squared minus 4ac must be less than 0. I want you to think about where we got the b squared minus 4ac from. It's coming straight from our minus b formula. In the minus b formula, b squared minus 4ac is in the square root. So I'm referring to having a negative number in the square root. And until you've studied complex numbers, you've always been told that you are not allowed a negative number in your square root. Your calculator would give you an error if you put it in. However, when we study complex numbers, we'll learn how to deal with things like the square root of minus 9, or how we could actually deal with it. So in terms of algebra, all you really need to know for quadratics with no real roots, to prove it, you have to prove the discriminant is negative. Okay, so let's have a look now at how all of that theory can come together in an exam question. I could give you the quadratic equation x squared plus 4x plus k equals 0. And I could ask you to find the range of values of k for which the quadratic has two real roots. First of all, if you see range of values, the way that we mathematically display ranges is with an inequality. So if you're asked for a range of values, it implies that your answer is going to have an inequality in it. And when you see that you need to prove the quadratic has two real roots, the very first thing that you should write down is you need to recognize that this is what I refer to as scenario number 3. If a quadratic has two real roots, that means that b squared minus 4ac is either greater than or equal to 0. So I need to sub in my a, b, and c, find the range of values of k for which the quadratic is greater than, for which the discriminant of the quadratic is greater than or equal to 0. Remember that the a, b, and c come straight from what we use in our minus b formula. A is the coefficient of x squared, which is 1, b is the coefficient of x, which is 4, and c is the constant at the end, which in this case is a k. If I sub in here, b squared becomes 4 squared, and I get minus 4 times 1 times k is greater than or equal to 0. If I simplify this, 4 times 4 is 16, and minus 4 times 1 times k just gives me minus 4 is greater than or equal to 0. Now, all I need to do now is bring my k's to one side, my numbers to the other side. So I'm going to add 4k to both sides, and I'm going to get 16 is greater than or equal to 4k. And if I divide both sides by 4, I get k is less than or equal to 4. Or in other words, 4 is greater than or equal to k. So the range of values for which this quadratic has two real roots is if the value for k is less than 4. If k is less than or equal to 4, then b squared minus 4ac must be greater than or equal to 0, and that implies that the quadratic will have two real roots. So I'm going to give you a few questions here that, based on this theory, you should be able to solve. So I want you to complete 3 questions in order to practice this material. The first one says to find the range of values of t for which x squared plus 8x plus t equals 0 has two real roots. In the second one, you're looking for the values of t for which 4x squared plus tx plus 25 equals 0 has two equal roots. And in question 3, you have a quadratic x squared minus x times 2t plus 2 plus 5t plus 1 equals 0. And you're looking for the values of t for which this quadratic has no real roots. So I want you to pause the video now, and I want you to attempt those questions yourself and then compare it to my solutions. So in question 1 here, I asked you to find the range of values for which this quadratic has two real roots. This is what I referred to as scenario 3 at the start of the video. If a quadratic has two real roots, that means they're either two equal real roots or two distinct real roots. So it means that the discriminant is greater than or equal to 0. So that's the first thing you should write down in a question like this. In this quadratic, a is 1, b is 8, and c is t. So I'm going to sub into b squared minus 4ac, but I'm going to sub in I'm going to sub in 1, 8, and t. And when you do that, you get 64 minus 4t is greater than or equal to 0. So obviously my goal here is to isolate t, so I added 4t to both sides. What I did then was divide both sides by 4, and if I divide both sides by 4, I end up with t is less than or equal to 16. So if t is less than or equal to 16, then this quadratic will have 2 real roots. In question 2, you were asked to find the values of t for which 4x squared plus tx plus 25 equals 0 has equal roots. In order for a quadratic equation to have equal roots, then the discriminant must be equal to 0. In this case, a is 4, b is t, and c is 25. So if you sub in, you should end up with t squared minus 400 equals 0. Now, the question asked me to find values. It's a plural. You want to find 2 different values. Anytime you have a variable to be squared, there are 2 possible answers. If the question had said find the value of t and didn't ask you for values, then it would be acceptable. If t, you could have just worked out one answer, you would have just ended up with t equals 20. However, if the question said values, you want 2 different answers. So if you have t squared minus 400 equals 0, you should view this as the difference of 2 squares, factorize and solve it, and the 2 possible values for t are t equals 20 or t equals minus 20. In maths, often we ignore the fact that there's 2 possible answers. If the question had just said find the value of t and it only asked you for 1, we would ignore the negative possibility here. If the question had just said value, what I would have done after this, you could have added 400 to both sides and said that t squared equals 400, and then the square root of both sides, you would have ended up with t is equal to 20. That's what you would have done if the question had implied that they want 1 answer. But if the question implies 2 answers, you should solve it like this, get t equals 20 or t equals minus 20. Now question 3 here is a really important question. It says find the range of values of t for which this quadratic has no real roots. If a quadratic has no real roots, that means that b squared minus 4ac is less than 0. In this case, a is the number in front of x squared, it's a 1. B is the coefficient of x. In this case, you had to take the minus and the 2t plus 2. If I multiplied minus by 2t, I'd get minus 2t, and minus by 2, I'd get minus 2. So the b, or the coefficient of x in this case, is actually minus 2t minus 2. And then c, the constants that don't have any x's in them, are 5t plus 1. So that's my a, b, and c. What I've done is I've just subbed into b squared minus 4ac. And you have to multiply minus 2t minus 2 by minus 2t minus 2. If you multiply out that as double brackets, you'll get 4t squared plus 8t plus 4. And if you multiply minus 4 by 5t plus 1, you get minus 20t minus 4. When I grouped my like terms together, I now have 4t squared minus 12t is less than 0. Now this is really important. In a previous video, we did an entire video dedicated to quadratics with an inequality. Even though I'm going to factorize this one differently, even though there's only 2 terms, this is still a quadratic curve. I could still represent this as a quadratic curve because I have a t squared in it. If you have a t squared or an unknown to be squared and an inequality, the only way to finish this question off is to let it equal to 0, factorize and solve it, sketch a curve, and then identify when is the curve less than 0. So even though this one looks a little bit different to ones we did in previous videos, because there's a t squared and an inequality, we're treating it the exact same as we did the quadratic equations in previous videos. So the question posed here is 4t squared minus 12t is less than 0. In order to answer that, I need to let the quadratic equal to 0 and I need to factorize it. In order to factorize this, you simply take out the common term. The thing that's common to both of these is 4t, and that leaves me with t minus 3. So now I have my 2 factors. I can just let each factor equal to 0 and find my roots. So the roots end up as t equals 0 and t equals 3. It's a plus t squared, so I know it's a U shape, crosses the x-axis at 0 and the x-axis at 3. This rough sketch of a quadratic allows me to answer the question posed. I'm trying to work out when is 4t squared minus 12t less than 0. It's less than 0 when it's below the x-axis. Clearly, when I'm dealing with values for t between 0 and 3, it's below the x-axis. So in this case, my answer will be that t needs to be greater than 0, but it needs to be less than 3. If t is greater than 0 but less than 3, then this quadratic is below, and this quadratic is less than 0. And I know that when this is true, b squared minus 4ac is less than 0. So these are the values for t for which the quadratic will have no real roots.